All right, let's look at the homework 7, problem number 10. All right, so first we want to find its critical numbers. All right, so let's do that. All right, so we take the derivative. So f prime of x is equal to, all right, so we're going to square the denominator. So you have x minus 2, and we square that. All right, derivative of the top is 2x. Times the denominator is x minus 2, minus top is x squared, multiplied by the derivative of the denominator is just 1, right? So let's clean up a little bit. So what's in common? Let's see. First, let's take care of the denominator. All right, so we have x minus 2 squared. That looks good as it is, so I'll just keep that. All right, so we took care of this. All right, then we have x here, and we have actually two of those, x there. So x, I'm going to pull out x, right? And what's left is 2 distributed to x, so that would be 2x. And also 2 distributed to negative 2, so that's negative 4. So I put negative 4. Alright, then we have negative x there, so you have to subtract x there. Alright, so this is going to be x times x minus 4 over, alright, x minus 2 squared. Alright, if you set this guy equal to 0, and we can see that we can set the numerator equal to 0, so we know that x equals 0. And x equals 4. Those are the critical numbers. All right, so let's type it in. All right, so we have 0 and 4. All right, let's check the answer. All right, we got that. All right, then we want the increasing interval, so we're going to have to do the number line. So I'm going to do a number line here. All right. So function is not defined at 2, so I'm going to put the 2 here, and 0 here, and put 4 here, right? Then we just have to check the sign, right? So we're going to try, let's see, anything below 0. So we're going to look at the f prime of negative 1, right? So if you put negative 1, so I'm looking at this guy right here, right? So denominator is always positive, so we don't have to worry about this guy. So we just have to worry about the sign of the numerator. So here, x is negative, right? Then negative 1 minus 4, so it's negative, negative. So negative times negative is going to be positive here. All right, between 0 and 2, so we're going to try 1. All right, then if you try 1, 1's positive, 1 minus 4 is negative, so this is going to be negative there. All right, between 2 and 4, so we can try 3. All right, 3 is positive, but 3 minus 4 is negative, so it's going to be still negative. And anything bigger than 4, so we can try 5, so that's going to be positive. All right. So we know that the original function f is going to be increasing here and decreasing here and still decreasing there and increasing there. Right? So increase interval before 0 and after 4. So let's put it in. So function is increasing from negative infinity to 0, right, comma, and then 4 to positive infinity, right? So let's use comma to separate. So let's check the answer. All right, we got that. And then it's a decreasing on, right? So we know that it's going from 0 to 2, right? And then 2 to 4. Because we have to skip 2 because function is not defined there. All right, let's check the answer. All right, we got that. All All right, then which statements regarding, so we want to look at a local max and local minimum. All right, so you can see that here it's increasing turned into decreasing. So at this point, you're going to have a local maximum, right? At 2, function is defined as nothing there. And here, we have a decreasing turning into increasing. So you're going to have a local minimum there, right? So you have a maximum at 0, minimum at 4, right? So local, let's see, at let's see which one. All right, max is at 0. All right, sorry about that. So maximum at 0, minimum at 4. So answer is B. All right, let's check the answer. All right, we got that. All right, that's it. I hope that this was clear.